Hi everyone. So in the last video I gave you the question to write the code for delete ith node. We were discussing delete ith node. So I gave you the question to write the code for this function. So now in this video we will discuss the approach and we will also write the solution. Okay, so let's take one example. So if this is my linked list 1, 2, 3, 4 and 5 and I want to delete the node present at index 2. Okay, so the value of 5 is 2. So this is 0, this is 1, this is 2, this is 3 and this is 4. Basically I want to delete this node. I want to remove this node from my linked list. So again the approach is very simple. So what you have to do, I will reach here. So for reaching here, how many iterations, how many jumps? Only one jump. So that means if the value of 5 is 2, I will take only one jump. That means I will take I minus 1 jumps. So after doing I minus 1 jump, I will reach at this position. So let's suppose the name of this node is current. Then what you have to do, so in order to remove this node from my linked list, I have to make this connection. And for making this connection, I told you in the last video, I gave you a very big hint what you will write. So the next of current is equals to next of current. Simple. We have to make this connection right. So for making this connection, the next of current, so this is the next of current and this is next of current. So next of next. So this 2 will now point towards 4. And what will your linked list look like? So again this is 1, then 2, then basically 4 and then 5. And this will be node 3. So node 3 is also pointing towards this node 4. And this node 3 we do not have the address of the node 3, and this is basically called memory leak. Memory leak means, so you have some memory allocated inside your heap memory. So this is heap memory. So you have some memory allocated inside your heap memory and we do not have the address of this memory. So basically this memory is totally a wastage of our space. Okay, so it is called memory leak and it is a very bad practice. So this will be my linked list and this is my head and I will return my head. Simple. Okay, and the special cases, if the value of I is 0. So this is your linked list 1, 2, 3 and 4. The value of I is 0. So you want to delete your first node. So this is your head. So what you have to write? You will simply write return head arrow next. Simple. So return head arrow next. What is the meaning of this line? So it means that return the address of this node. So you will return the address of this node and I will return the updated address in main. So basically my linked list will become 2, 3 and 4. Okay, so in main my linked list will become 2, 3 and 4. So very simple. So for the value of I equals 0, return the next of head, and otherwise we will do something like this. So it is very simple. Okay, again now to check for the valid values of I, so first option is with the help of length function, but we have discussed many times there is no need to call the length function. We will just take the help of this condition. Okay, we will just take the help of this condition and we will check. So if head exists, then we will do something like this. Okay, simple. So now let us write the code. So I'm not copy pasting the code this time. So let's write the code from fresh. So the return type will be node star because I will return the head of the linked list. So node star, and the name of the function is delete ith node. What it will take? So it will take head as input, it will take linked list as input, and it will also take the index. Now again the first condition is very simple. So if the value of I is basically less than 0, then basically do not do anything. You can simply return the head. Now if the value of I is 0, that means you want to delete the first node. So for deleting the first node, what you can write? We can write head arrow next. Okay, so you can write head arrow next. So if you are writing head arrow next, basically you are returning the address of the second node. Okay, so the meaning of this node is basically, you can see, so we are returning the address of the second node. So first node is getting deleted. Okay, now one thing here, so suppose your head is null. That means your linked list is empty, and what you are doing here, so you are returning null arrow next. So that means you will get runtime error. If your linked list is empty. So it is better to write a check here that your head should exist. Then only you can do this operation. Okay. So if I is 0 and basically your head exists, that means your linked list exists, then only you can do this operation, and you can similarly update the rest of the code yourself. Okay, so here what we are doing, so this is fine, there is no need to write head condition here, so it will work fine. Okay, so yeah, so now what you have to do, so we have to iterate. Now this time for iterating I am taking a current pointer, same as temporary pointer. Okay, so this current is actually your head, and again a count. So how many times I have to run the loop? I minus 1 times. So again, while count is less than or equals to I minus 1. So I am writing exactly the same condition that we have seen above. So while count is less than or equals to I minus 1 and my current exists, that means my current is not equals to null. So what you have to do, move ahead. So for moving ahead, current equals next of current, and we will do count plus plus. So this is exactly the same code that we have wrote above. Now after doing this, so if my current exists, then what you have to do, so we have to do something, we have to copy paste this code. Okay, I have to write this line. So let us write this line. So the next of current is next of current, and then basically what you have to do, we have to return head also. So return head. Now in the else part, or there is no need to write the else part. So if current does not exist, there is no need to do anything and you can return head. So do you think this code will work? So let me erase the screen. Okay, so my question is, do you think our code will work or there is some problem with our code? So I think there is some problem with this part of the code. Okay, so there is some problem with this part of the code. And what is the problem? So suppose what you are writing here. So we are writing current, next of current is next of current. Fine. Let's take one example. So if this is my linked list 1, 2, 3 and 4, and let's say the value of I is basically 3. So this is 0, this is 1, this is 2 and this is 3. That means I want to delete the node 4. Okay, I want to delete node 4. So if the value of I is 3, I will jump 2 times. Okay, I will jump 2 times. So this is my first jump and this is my second jump. So this is my current pointer. Okay, so current exists. Yes, current exists. So the next of current, that means the next of 3. So I am writing here. So next of 3 is basically, so what is this part? Current arrow next. So what is current arrow next? So current arrow next is basically 4. So we are doing 4 arrow next. Okay, and what is 4 arrow next? So 4 arrow next is basically null. So basically this right hand side, so this part is actually null. Okay, so we are doing the next of 3 is null. So next of 3 is null. So what will be my linked list? My linked list is now 1, 2, 3 and null. So this is my updated linked list, which is correct, and this 4 again. So what we are having here, so this 4 belongs to memory leak. So this is basically memory leak. And what is memory leak? So we have some memory allocated and we do not have the address of this memory. So that means we cannot use that memory. Okay, I am repeating myself. Memory leak is there is some memory which has been allocated by your program, but there is no way to access that memory because we do not have the address of that memory. Okay, so this is fine, I think. Now let's take one more example. So instead of the value of i3, let someone give the value of i4. Someone is giving the value of i4. Okay, and we know this is basically not a valid index. So our code should work for this valid index also. Okay, ideally our code should handle this. Now let's see whether our code is handling this or not. So what will happen? So I'm writing here again. So this is my linked list 1, 2, 3 and 4. This is my linked list. The value of I is 4 and this is basically invalid index, and I will try to show you that our code is not handling this case. So the value of I is 4. How many times I will take jump? So I will perform 3 jumps. Okay, I will perform 3 jumps, 3 iterations. So this is the first iteration, this is the second iteration, and this is the third iteration. Okay, fine. So this is my current now. So now let's check if current exists. Yes, current exists. So I will go inside the if part. Ideally what should happen? I should return head because this is not a valid index, but I am going inside the if part. Okay, so let's go inside the if part, and what we are doing, so current arrow next, what is current? 4. And what is 4 arrow next? So 4 is pointing towards null. Okay, so let's write here also. So I am writing above it. So current arrow next, what is current? Current is 4. So 4 arrow next. Okay, so what is next of current? So what is current arrow next? So current arrow next is actually null. So I am writing here null. Okay, so this part is actually null, and then we have next. So null arrow next, and you can see it yourself. What we are doing here, we are doing a null arrow next, and what will happen? We will get a runtime error or segmentation fault. Okay, so this is the problem. So our code is not handling this case. If the value of I is basically invalid, then our code is not handling this case properly. We will get runtime error. So what we have to do, so instead of checking current, we have to check current, but we also have to check the next of current should exist. Okay, so see, I am accessing next of current. So that means current should exist, right? Here I am accessing next of current arrow next. That means current arrow next should also exist. Okay, so here I am checking only for current. So we have to add this condition also. So let me add this condition. So instead of checking current, you also have to check for next of current. Okay, so I am repeating myself. Let me clear everything else. So we are writing this part. Current arrow next is next of current. So the blind rule is, so very simple rule is, you are accessing next of something. That means that thing should exist. Okay, so that's why we have been writing this condition. If head exists, if current exists. So that means you have to write this condition because you are accessing next of that thing. Now here what we are doing, we are accessing next of this thing. So that means you have to also write this condition, current arrow next. Simple. Whenever you are accessing next of something, make sure that thing is basically that thing exists. Okay, so I am repeating myself. Whenever you are accessing next of something, make sure that thing is existing. So we have to write this condition also. Now if you will write this condition, then our code will work for I equals 4. Okay, why? 1, 2, 3, 4. This is my linked list. and these are the indexes 0, 1, 2 and 3, and we know index 4 is basically invalid index. So how many jumps we will take? 3 jumps. Okay, so we will do 3 jumps. So first jump, second jump, third jump. So this is my current pointer. Now I will check the if condition. Current exists, so current is node 4, yes, but we have AND operator, so we will check the next condition also. So current arrow next exists. So what is current arrow next? It is null. So that means the next of current not exist. So this condition will become false, and we will return head. We will return head. So our code will now handle the invalid values of I also. Simple. Okay. So now let us try to test our program. So semicolon here. Okay. So I think our code will work. So let's call this function delete ith node. So there is no need to call insert at ith node function, so I'm commenting that part. And similarly, there is no need to take data as input. Okay, we have already tested that program, so I will take only index as input. So int I, say in I am calling the delete ith node function, and we have to pass the linked list. By linked list we have to pass the head and we have to pass the index. So after passing these two things, we are calling the print function, so it will print our linked list. Okay, so let's test our program. So the data is, let's say 1, 2, 3 and 4 minus 1. So my linked list is 1, 2, 3, 4. It is waiting for index, and let's say I want to delete 0th node. Okay, so my linked list should be 2, 3, 4, and this is my linked list 2, 3, 4 and null. Okay, let's give one more value 1, 2, 3, 4 minus 1. Let's say I want to delete the node present at index 2. Okay, so this is my new linked list 1, 2, 4 and null. So this is index 2, 3 is present at index 2, so 1, 2, 4 and null. Now let's try to delete the last node 1, 2, 3, 4 minus 1. So I want to delete the node 4. So node 4 index is 3. So index 3 and 1, 2, 3 null. Okay, so our code is working. And now let us try to give the invalid values 1, 2, 3, 4 minus 1. Invalid value is 4. 4 is the invalid value because index 4 does not exist. So our code is working fine. We are not deleting anything. Okay, we are not deleting anything. Our code is working fine. Now let's test. The last test we have to do is for the negative values of I. 1, 2, 3 and 4 minus 1. Negative value, let's say minus 3, and our code is working 1, 2, 3, 4 null. Okay, so basically our code is working perfectly fine, but the only problem with our code is, so where is the code? Okay, so we have already discussed there is one problem with this code. And what is that problem? So there is memory leak. Okay, there is memory leak in our code, and what we will do, so in the next video we will fix this memory leak. So I am repeating myself again. What is memory leak? For example, in this case, what is happening? Okay, so we forgot to test for this condition when head, basically when my linked list is empty. So I will check for this condition also. So what is memory leak again? So if this is your linked list 1, 2, 3 and 4, and if the value of I is 0, so what I am doing, I am returning head arrow next. I am returning head arrow next. So basically this is your head, I am returning head arrow next. I am returning the address of this node. So this is your main, and you are receiving head here. So basically you are returning 2, the address of the node 2. Okay, so your linked list will become like this, and your 1 is present in the memory, 1 is there in the memory, and you do not have the address of this memory, and you cannot access this memory. So this is the problem. Problem is called memory leak. And similarly here also, if you want to delete the node 3, I am doing something like this. Okay, so basically your linked list will become 1, 2, 4, but there is node 3 also which is pointing towards this node 4, and we do not have the address, we do not have the access of this node. So basically we are wasting our memory, and again this problem is called memory leak. Okay, so in the next video we will fix this memory leak problem. Now let's test for this condition when my linked list is basically empty. So my linked list is empty, and let's say I want to delete 0th node. So I am returning null because my linked list is empty, so I cannot delete anything. One more time. -1 means my linked list is empty and delete the node present at index 5. So I cannot delete anything because my list is basically empty. Okay, simple. So what is your homework? So if I want to allocate the memory, I have to use new keyword. Now if I want to deallocate the memory, then I have to use delete keyword. And if you can see, in this whole function, I am not using delete keyword anywhere. So that means we are not deallocating the memory. Now try to figure out yourself how we can use the delete keyword. Okay, so this is your homework. It will be a good question for you. Okay, so do give it a try, and you can watch my solution in the next video. Okay, so I will see you there.